All right, today we are covering 5.3 equations of lines, scatter plots, and regression lines. And students should be able to write linear equations with 80% accuracy by the end of the lesson and still get their homeworks to 100%. All right, let's get started. So point slope form. Okay. This is point slope form. There's a y, a y1, an m, an x, and an x1. Okay? I promise this is not as horrible as it looks. So let's get into it. The point slope form is important because you only need a point and a slope, and it can be simplified into slope-intercept form. So here we go. If we know the slope of a line and a point not containing the y-intercept through which the line passes, we can use the point-slope form of an equation. Once we have obtained this equation, solve for y, and then write the equation in slope-intercept form. So, example, write an equation in slope-intercept form for the line that has a slope of m and passes through x1, y1. So the first step we're going to do is substitute the slope in for m. Yeah, right there, m. That's your slope. Whatever slope they tell you, you just write it right there. Then we have the point x1, y1. x1 goes there, y1 goes there. Simplify any addition or subtraction. So if you're subtracting a negative, make that a positive. And then you're done. To get slope-intercept form, you want to keep simplifying. So let's go for an example. Find the point-slope form of the equation of the line passing through 1, 4 with a slope of 2. 2 is the slope, so that goes where the m is. 1 is the x of our point, so that goes where the x1 is. 4 is the y of our point, so that comes on over here. And that's all you have to do. You just substitute those values in, and behold, you have point slope form. That's really, honestly, all there is to it. You substitute in the slope, the x and the y, and you write it down. Now we want to find the slope-intercept form. So the first thing we're going to do is distribute that 2 to the x and the minus 1. So you might want to write down that we distributed. You could put the arrows in if you like. Now, once we've distributed, which is always our first step, going from point-slope form to slope-intercept, then we need to get rid of this minus 4 by the y. How do we get rid of minus 4? Oh, we add 4. So we're adding 4 to both sides. That'll clear up this mess over here. And we, write this down. Add to get y by itself. And we end up with y equals 2x plus 2. Et voila, slope-intercept form. Honestly, this is all you have to do to get from point-slope form to slope-intercept form is you first distribute and then add or subtract whatever is by the y. So if it's minus, you add. If it's adding, you subtract. Okay, let's do another one. So you can also use point-slope form to find the equation of a line if you're given 2 points on a line. So we have the points 1, 2, and 5, 1. So our x1 and y1, and our x2, y2. I don't know where y2 went. Oh, there it is. And so we're going to fill in our y2 minus y1 over our x2 minus x1. And then we do 10 minus 2 equals 8. 5 minus 1 is 4. 8/4 is 2. Then we're going to enter one of the ordered pairs and the slope into the point-slope form. Now, in general, I am a creature of habit, so I just usually stick to the first point. Doesn't matter though, either one will be okay. So we have a slope of 2 that goes in where m is. X just stays there, minus x1, which is 1. And over here we have y minus y1, which is 2. And that is it. There's your point slope form, all done. So write the point slope form of the equation of a line with the points -1, 4 and -4, 5. How am I going to get started? Well, we need to figure out what m is. How do we do that? Oh, we have a handy dandy formula. So there's our slope formula. We're going to take our x1, y1 and x2, y2 and fill in the blanks. So we have 5 minus 4 all over -4 minus -1. That's the same as -4 plus 1. So it's -1/3. So now that we have our slope and our x1, y1, we just stick that all in there. So y1 is our 4, x1 is our -1. We minus -1, we get a +1. So there we are in point slope form. We just need to turn ourselves into the y equals mx plus b next. So yeah, there's point slope form. So the first thing we're going to do now is we're going to distribute that -1/3. So y minus 4 stays the same. We get -1/3 times x. -1/3 times 1 is -1/3. Now we have to get rid of this 4 over here. So we're -4, so we have to add 4. What? What are we doing? Yeah, that's ugly. We can't really do that. We need common denominators to add fractions. How do we do that? Ah! Don't worry. I know what to do. We'll come over here. We've got 4 over 1 times 3 over 3 gives you 12/3. So then we have a common denominator. So we can just do -1/3 plus 12/3 is 11/3. Note that the bottom stays the same. So pretty much if you had 4 sandwiches that you were cutting into 3 pieces each, you would have 12/3 of sandwiches, right? If you take away one of those thirds, now you have 11/3 of sandwiches. All right. So we get y equals -1/3 x plus 11/3, and that's our slope-intercept form. Now, scatter plots and correlation. Correlation is used to determine if there's a relationship between two variables, and if so, the strength and direction of the relationship. So regression lines and correlation coefficients. A regression line is a line that best fits the data points in a scatter plot, and the particular line in which the spread of the data plots around is small. Correlation coefficient measures that is used to describe the strength and direction of a relationship between the variables whose data points lie on or near a line. And that's designated by R. And R goes anywhere from -1 to +1. -1 would indicate a strong negative correlation, and +1 would indicate a strong positive correlation, and 0 would indicate no correlation. So let's look at them. So, okay, R equals 1 over here in graph A was a perfect positive correlation. The perfect positive correlation is something along the lines of the more this virus continues, the more irritable Ms. Lons is getting. Whew. The strong positive correlation would be something along the lines of The faster Miss Lons drives in her little red car, the more likely it is that she's going to get a speeding ticket. It doesn't always happen. Actually, that one might be more like this, where I really don't get terribly many speeding tickets. The likelihood is good. If I run into a cop, I'm going to get one. But generally, in the 30 miles I drive to school every morning and back, I pretty much know where they are. So I'm pretty good at avoiding them, but they do get me every once in a while. So that's a moderate to weak positive correlation. No correlation would be the more I keep my house clean and the more money I get for teaching. They are totally unrelated. I could have the most sparkly clean house with no germs on the floor, and it is not going to make any difference as if I had a filthy pigsty for a house. It doesn't matter what my house looks like in the eyes of our superintendent and how much money I'm going to make every year. Okay? A moderate weak correlation or a strong negative correlation. These might be things that like I don't know, like something that as one goes up, the other goes down. So uh, the the more I exercise, and then this would be the amount I weigh. The more I exercise, is that going to decrease the amount I weigh? Probably it would if I didn't eat any chocolate, or pasta, or, snack at all, and I ate more vegetables, you know. But yeah, if you don't change your diet, your weight's not really going to go down much. A strong negative correlation might be something like the more hours of sleep I get, the less grouchy I am. It doesn't always work because if you sleep too long, you kind of can get a backache, I've heard. And I haven't had much sleep today and I'm still feeling pretty good. So it's not 100%, but in general, a perfect negative correlation is um the the more mm, the more I study, the less partying I'm going to do, or you're going to do, because I don't party anymore. I'm a much too old. Not really, but no, like if you're studying 10 hours a day, you are not also partying 10 hours a day. There's just not that many hours in a day. Um, so I'm sure there are better things for the more daylight we have in a day, the electricity usage will go down because I'm not keeping my lights on in the sunlight. Anyway, so that's it for today. I hope you have a wonderful day, and I will see you when I get back.